This is our topology. We advertise the networks, and we change the priorities. We change the costs to choose which is the best path should be chosen. If you want to manipulate, you can do that. I can go to interface giga 0 by 1 again. If you want to default now IP OSP of cost 1, I can choose. And again, whenever the costs are changed, again they will choose which would be the best path to send and receive the data. Now in router 3, if I give the command show router 1, if I give the command show IP OSP of neighbor.
So I can't hear you.
Oh, when I give the command show IP OSP of neighbor, you see actually 10.1.2.1 is working like a DR, 10.1.3.1 working as a VDR. Yeah, no, that is clear IP, go with clear IP OSP process. IPS, 1 minute. You have to do it in router, let us do in router 2 also once. Clear IP OSP process. Clear IP OSPF. So if I give the command show IP OSP of neighbor, yeah. So they are into the some two states is happening. I'll explain it this way. Oh, router is two-way state. Now if you observe here, router 3 is DR, very good, and router 3 is DR, and router 2 is VDR. Now it is done. Before you see it was two-way state with 2.1, two-way state. Now if you observe here 10.1.3.1 is a DR, designated router, and router 2 is an APDR. Why? You see, you remember in our last class again, I was telling you how Ospf will select DR and BDR. DR and BDR is selected based on the priority. Based on the priority. But for all the routers, they have the same priority. Priority 1, 1, 1. Router 1, router 2, router 3. All three routers, they have the same priority. Now it is going to take the importance of the router ID. The router which has a highest router ID will become DRI side. So router 3 is loopback is 10.1.3.1, which is greater than 10.1.2.1, 10.1.1.1. So router 3 is working as a DR, router 2 is working as a BDR, router 1 is DR others. But I want to make router 1 as a DR manually. So we can change by using the cost, by changing the priority. So what I do, I'm going for the interface giga 0 by 1. IP OSP of cost, IP OSP of priority, IP OSP of cost, both are done here only. So IP OSP of not the cost, priority. I'll give, so priority can be given 0 to 255, I can give 255, the highest. No other device should be there. Now on router 2, what I do, this is in the case of router 1, I'm sure. Okay. And in the router 2 also, I'll give the priority for its giga 0 by 1. 150 interface giga 0 by 1. IP Ospf priority 254. And the next one is 1. Okay. Then you need to check in the router 3. If you give the command show IP Ospf neighbor, show IP Ospf neighbor, 10.1.2.1 is working as a BDR, still 10.1.1.1 choosing as a other one, DR others one. But whenever you configure, if some according to our task, if it's not coming, you need to clear IP Ospf process. So don't do this simple command in the production network. When you give clear IP Ospf process, the neighbors are being lost. The neighbors are getting lost, and it is going to be reset for 10 seconds. So there can be downtime. Clear IP Ospf process. Here, IP Ospf process. There is no star or stop. Just you have to give enter. So router 2 and router 1 we have done. Now if I am going for VOS 3, router 3, if I use the same command, show IP Ospf neighbor, then 1.1.1 is taking BDR, 10.1.2.1 is taking again DR other. No. So IP Ospf neighbor, 10.1.1.1, still it is working as a DR using 3.1. 10.1.2.1, priority is 254. 1 is 1. Let's do clear IP Ospf process in router 3 also. Clear IP Ospf process. Yeah. Now if you observe here, router 1 10.1.1.1, its priority is 255. A router which has higher priority become DR, and the next lower priority will become VDR. Clear IP Ospf process must be given. Now in router 3, if I give the command P to 10.1.1.1, the source 10.1.3.1 should I get reply, and if I am trying to repeat 10,000 packets are sending. Meantime, if router 1 interface 150 interface giga 0 by 1 shut down, this path will be down because the best path is lost, and once the secondary path comes again, it will choose the router 2 to router 1, the other path. So in the switch we need to configure uplink fast, so it takes some time actually, because the interface is down now. To choose another path, it takes minimum 30 seconds. Avoid these things. On the switch you can configure something called code fast. Code fast are there. Interface range gig, span and tree Mode fast, record. But now the second link is up, you're sending the data. So here you see that when the best path is down, so choose so the dead period is expired, the neighbor is dead. That's then giga 0 by 1. Then another path comes up, so it sends the data to router 2 to router 1. So this is the first day lab. Okay. We try to understand how to configure Ospf in area 0, how Ospf is working, how Ospf is making adjacencies, what is the importance of the cost, how DR and BDR is selected. So what we do in tomorrow class, I'll explain you Ospf states, I'll explain you Ospf stubs concept. Okay, sir. See you tomorrow. Yeah.